for today, we're looking at just the hyperbola, not hyperbola, but hyperbola. And this occurs when the C value of the foci that comes from the center and starts working its way out of the ellipse. What happens if that foci leave the ellipse and they go outside of the ellipse? That's where we get this new shape called the hyperbola. Right? And I created this Desmos here, which illustrates all the different aspects of it. They can open left, right, or up and down. You have your A's and you have your B's. Right? And you get this sort of shape. You have your foci that are on the outside, not on the inside anymore. Right? But they can open left and right. They can open up and down. Right? Something like this. Go either direction. Have both of them. So you can see there's a lot of dotted lines here, and you actually make those first, and they guide your graph. So the first part is the dotted lines. They're not actually part of the graph, but they guide the graph, so you have to put those in. So it's a little different, something we didn't have before, but more or less all the rules are the same. Okay? So the first thing about it is, how do you know if this wasn't the section called hyperbola? How do you know it's hyperbola? Right? So the first thing is to notice that we have subtraction signs in the in the standard equations. They're still equal to 1, just like the ellipse. But if one of the squared terms happens to be negative, not both, but one, then that's when you get a hyperbola. So you can tell here in the general form that the y squared has a negative, so you know it's a hyperbola. On the test and quizzes, when you're taking those, you will not be told what it is. It'll just say graph it. Right? You'll just have to graph it and know what it is. Okay? There we are. Alright, so let's see here. What else we got? Got the same A, B, major and minor, right? However, the A is always going to be listed first. So it's always listed first, as opposed to where the ellipse, it could be whatever way it's actually stretching. Okay. So if it's opening left and right, it's going to have the X first. Open up and down, we're going to have the Y first. Right? Another way of looking at it is whichever one is positive, that's the direction it opens. So a lot of little details, but nothing we can't handle. All right, so let's get right to it. Find the center, find the vertices, find the foci. We're going to have these asymptotes, right? That's what we have right here, these dotted lines. And we just need to find the slopes of them, okay? Just by finding the rise and the run. All right, so first things first. Let's do center and just write it out. We got center. Right? And why would this be wrong? So we got 3 and we got -1. So why is that wrong? Spot it. What do you see? You see it now? So this is a little different, right? The y's and the x's can be in any order depending on the problem. So that's a new thing to watch out for. So we have to find, okay, what is the x? And find x. So that's -1. What is the y? Find y. Okay. So these are the little things, right? So it's not really how well do you solve math problems and equations, but can you spot and look at the little details. And then as we go along, of course, let's actually graph this. That's 1 right there. Okay. And then we can look at the a squared is always going to be listed first. So that's a squared. So a is equal to 3. And since it's underneath the y, we're going to go up and down 3 from the center. So up 3 to -1, 6, down 3 to -1, 0. And we want to write those out. Those are the vertices. Always identified using A. So -1, 6 and -1, 0. Of course, we can do the B as well. Notice how B is actually bigger, right? So A is not the bigger of the 3 anymore. It's actually the smallest here. So we have b squared is 16. So we got to go 4, left and right, from the center. 1, 2, 3, 4. 1, 2, 3, 4. And now create the frame. So using these, go ahead and connect them all with dotted. Box all the way around. And with that, we can also create the asymptotes. So they go from corner to corner of the frame. Just goes right through the middle, right through the center, and out the next corner. They're all dotted because they're not actually part of the graph. They just help us do the graph. Okay. And we want to make it all the way through the frame, all the way to the end of the graph, all the way down. Trying to make it straight as possible. There we go. And one of the things we need to find, it does ask for it, is the slopes of those asymptotes. So you go there, find the rise and the run, and they're usually going to be in the form of plus or minus, because there's one going up, there's one going down. So the same slope, we have to go up 3, right 4, or up 3, left 4. So that gives us plus or minus 3 over 4. Some other places will actually ask you for the equation of these, and you can do that and find the y-intercepts and things like that as well. All right, so what's left? Check these off as we go. We did the center, we did the vertices, we need the foci. So foci is going to be up here, and now that C is the longest value, right? It actually is also going to be this value as well from here to here. Right? So we have A right here. We have B right here. This is the right triangle, and this is C. So the Pythagorean theorem is back because C is now the hypotenuse again. So for hyperbolas, you use A squared plus B squared equals C squared. C is the longer value. It's bigger than A, it's bigger than B, so it has to be on the right-hand side there. So finding foci uses the regular Pythagorean theorem. Go down here. Start off with A squared plus B squared equals C squared. A squared is 9, B squared is 16. All right, so we have a nice 3, 4, 5 triangle. And just positive answer only. So from the center towards the direction it's opening, up and down, we're going to go 5. So from the center, I'm going to go up to here at -1, 8. Then go 5 down to, let's see here, -1, -2. Yep, -1, -2. Good. All right. Okay? Yeah, that's everything, right? So we checked all the boxes. And then the last thing is just to sketch the graph right here. So what you do is you don't really use the foci, but use the asymptotes, right? And you get as close as you can to them, and you gradually get more away from them as you get close to the vertice. Hit that vertice, like bounce right off it, and then get gradually closer to the asymptotes, like that. Then do the same thing on the bottom, and try to make it as symmetrical as possible, of course. There we go. Don't want to actually touch the asymptote though, so if you touch the asymptote, try to do it again. Mine's crooked. There we go. That's better. Okay. Yeah. And I'll post this link so you can actually check yours as well, or just put it in as is. But so 3, -1, and 3. So I can go up here and change this to -1 and 3. Right there. The A was what, 3? The B is 9. No, B was what, 4? B is 4. And it's opening up and down, so you can just click that one on, like that, and there you go. And it'll give you all the coordinates, so it actually shows what the vertice coordinates and the foci coordinates and everything is. Okay. There you go. So easy way to check. All right. So that's the basic rundown. You can make some mental notes. How is this similar? How is this different from the ellipse, right? Because that's going to be the biggest thing once this comes on the test. It's not really graphing this is going to be, you know, you're going to get some practice today and tomorrow, but in the end, it's do you know all the rules and do you not mix them up with each other? So do you use the correct Pythagorean theorem like for hyperbolas, and do you use the alternate one for the ellipses? Stuff like that. So just have that in the back of your mind that you have to keep track of everything as you go. All right, next is the general form. So you have to complete the square. Just as we always do, nothing has changed, right? So you want to first identify, okay, this is a hyperbola because one of them is, you have two squared terms, one of them is negative, one's positive. They have to be different signs. Okay, they have to be different signs. So otherwise, do the exact same thing we've been doing. So pair the x's together, pair the y's together, and move the number to the other side. That has not changed. Leave space as you go. 9x squared plus 18x. Plus, leave the space. Minus 4y squared plus 32x. Leave the space. And then move the number over, which is going to be positive 91. Ah, thank you. Good. Okay, next, let's do some factoring. Take out the 9. So I have x squared plus 2x plus c, something to complete the square. And then also take out the negative 4, not 4, got to take out negative 4. So we'll have y squared, and then to get the 32, we need this to be a negative 8y. Common mistake. It's just a negative. So in the end, it's not going to be, did you do the equations right or the steps right? If there is a mistake, it's probably going to be just missing a negative. So just be careful right there. Now to complete the square. So half of 2 is 1. Right? And we can write this as 9 times x plus 1. And then we have to add that to the other side. So we're going to add the 1, but then also the times 9. And then we can complete this square. So we'll have y minus half of negative 8, negative 4. Square negative 4, 16. And then we have to add that to the other side as well. Plus 16, but times negative 4. Times negative 4 in front. Okay. So Find, what does that equal? 91 plus 9 is 100. 100 minus 16 times 4. 16 times 4 is 4 times 4 times 4, 64. So that should be 100 minus 30. 100 minus 64 is 36, I believe. Yes. All right. Then get it equal to 1. Divide both sides. And then we will be in standard form. We got x plus 1 squared all over 4 minus y minus 4 squared all over 9. Now from there, go ahead and find the center, the vertices, the foci, the slope of the asymptotes. Also pay attention to which direction it is open, up, down, or left, right. All right, need to know that ahead of time. Okay, so give that a go. Check with each other. I'll be around. So the A ended up being 2, right? And it's opening left, right, since X is first. All right, so the A is equal to 2. So that's why we went 2 to the left, 2 to the right. The B is equal to 3. We went 3 up, 3 down. Made the frame, made the asymptotes. And then we can go ahead and find the foci by doing Pythagorean theorem. So that would be what? 2 squared plus 3 squared. Right? Which is just, 4 plus 9. So you get 13. Square root of that, it's about 3.6. Yeah, about 3.6, so that's why the foci are right outside here, about 3.6. So find a way to organize your work that makes sense, that you don't get lost. I know on this problem there wasn't a lot of space, but when you're doing your own work on paper, leave plenty of room. Don't try to squeeze things into certain smaller spaces. That's where the trouble starts. Okay. All right, flip it on over. Let's look at the mystery problems here that we have to put together. Okay. So we got our vertices. Go ahead and plot those. So we got 1, negative 1 right about here. 1, negative 9 right about here. Just like the ellipse, the center will be in the middle. Okay. So the middle of negative 1 and negative 9 is negative 5. And is this going to open up, down, or left, right? Okay. Our vertices are vertical, right? Vertices are vertical, so this is going to open up, down. Yeah, so we have to write the y first. We have y minus something, and then minus x minus something squared equal to 1. I need to find my a and the b. Okay. So we got, what goes here? Plus 5. And then minus 1, which I already put in. Minus 1. Now we got to find a and b, which isn't too bad, right? So the length from the center to the vertice is a. Right? So this length right here, how far is it? It's just 4, so 4 squared, 16. Next, we need to find b, which is on the minor axis, and they give us the minor axis. They say that this is 6. Right? So all I need to do is take that whole length of 6. That means each one is 3 and 3. So 3 squared is just 9. Not too bad, right? And it doesn't say to actually graph it, so you don't need to finish it. It just, find the equation and you're done there. So that's it. All right, not too bad, right? A lot of the same skills that we've already been practicing. Let's see here. Lastly, we got some eccentricity. It's the same equation, but the eccentricity is now going to be bigger than 1. Before it was circular at 0, and right before 1 it was elliptical, but as soon as that eccentricity becomes bigger than 1, meaning the number on the bottom is smaller than the number on top, C is bigger than A, you've got a number bigger than 1. So it works the same way. So foci at 0, 8. So that's just, 0, 8 and negative 8. So that puts the center at 0, 0, 0, right? Yeah, center's at 0, 0. And does this open up or down or left or right? Very good, up and down. So the foci and the vertices always tell you which direction it's open. So if the vertices are over here were vertical, it's opening up and down. The foci are vertical, opening up and down. All right. And then let's see here. So I can start doing the equation. Now you don't need to write this as, since the center is 0, 0, you don't need to write it as x minus 0 squared. You can just put x squared. So we have x squared over minus, we have y squared minus x squared. It's opening up and down. That equals 1. And we have to use the eccentricity because we have the value of C. So remember, distance from the center to the foci, which is 8, that's the C value. So like we did with the elliptical problems, this is equal to C over A, so you can set up a proportion. So 4 over 3, and then 8 is C. 8 will go on top, and you can solve for A. And once you have A, you can find A squared, and then with A squared and C squared, you can find B squared, and that will be the second number. So we'll have A is equal to 6. When we solve that, so we'll have 36 right here. And then to get the B squared, you can just use Pythagorean theorem. It's going to be 64 minus 36, looks like. Which is 30, 40, 28, I think. Yep. So B squared is 28. Now, if we needed to actually graph this, I'd take the square root of 28 and go that distance left and right, but we don't need to graph it. So just graph as much as you need to get the information, the center, A and B squared, and then you're done. Okay. All right. So let's see here. We got a little bit of time. So see what you can get done today. Try to tackle maybe one of the more harder problems together, that the one you would not want to do by yourself. All right, do that one right now, and we'll see you tomorrow for some more practice.